Hello, this is the next video in a playlist that I'm calling General Linear Models Design of Experiments. And within that playlist I create little mini-series depending upon the design that we're studying. This little mini-series deals with analysis of covariance. And this is part 1 of 9 of a little mini-series. And this first one I'm calling Model Development. Now, analysis of covariance, what it does is it brings in ANOVA and regression and combines them, and that combination is called analysis of covariance, or ANCOVA for short. Now, the goal in ANCOVA is still the same goal that we have in analysis of variance, and that is to test the treatment effects on the response. Now, the drawback, so this is the setting. The drawback is that the response is linearly related to another variable called z. Now, z cannot be controlled, but it can be observed along with the response y. Now, z is called a covariate or a concomitant variable. Now, here is a model in scalar form. We're going to look at the one-way fixed effects ANOVA with one covariate. Now, the model is Yij equal to mu plus tau I plus gamma plus Zij minus the grand mean of z. So this is a centered variable plus epsilon. I goes from 1 to a, j from 1 to n. Now, Yij is the response for the ith treatment and the jth observation. Mu, tau I, and gammas are unknown fixed parameters. The Zij measurement on the covariate. Now, gamma must be independent of treatment, and that's actually a pretty important assumption. And the error term is IID, mean zero, constant variance sigma squared. Now, when we do confidence intervals and hypothesis tests, we'll require that to be normally distributed. Now, in a more general setting, in matrix form, it's still a linear model. So x star, beta star plus epsilon. So this is the generic, it's a linear model formula. But what we do is we partition this into x and z, and then these are the unknown parameters associated with those. But when we do this multiplication, this piece here deals with the balanced ANOVA. So X can be the design matrix for a one-way fixed effects ANOVA, a two-factor analysis, a balanced randomized complete block design. I mean, so X has a lot of possibilities. And Z can be any number of regression variables that we think are related to Y. And really, the goal of this is just like any other design where we add variables and add information to help us reduce the overall variability in the model, which gives us more power to test for treatment differences. Now, Z is we're going to center it. So that means that we subtract the grand mean of the variable, from it itself. And we kind of saw that in the scalar form. Now, the reason we do that, one reason we do that, is that the least squares estimate of mu is the grand mean, y dot dot bar. Now, mu is actually part of the ANOVA setting. And if you've watched any of the previous videos, that'll make more sense. But we'll also cover it in more detail as we proceed through this little mini series. So let's do the example that we just did in matrix form. So we're going to look at a one-way fixed effects ANOVA with one covariate. So the design matrix is this, and we enter the Y sorted by treatment and then observation. So this is Y11, so it's treatment 1, observation 1. Then it's Y12, so it's treatment 1, observation 2, all the way to Y1N. And then we keep going And then we get to the 8th treatment, and it's YA1, YA2, all the way to YAN. The design matrix is also ordered. The first one is all ones, and that's associated with the mu parameter. And then the next part of the design matrices are ones and then zeros, and perhaps I should write zeros here. And those are associated with the treatment effect. So when we take this beta parameter and multiply it over, when we're in these rows, it picks off the tau 1 parameter, and these are all zeros. And matter of fact, I better put that in there just for clarity. So this is the zero matrix, and this down here is a zero matrix. Now the covariate, so all the way to treatment A. Now the covariance is only one covariate, so it comes in, and we call it Z. So this is Z11, Z12, and these are associated or observed with the Y variables. And we center them. So what we do is we add up all of these, divide by how many there are, and subtract it from each one of those. So it's called a centered variable. The beta parameters in this one-way fixed effects ANOVA is mu, tau 1 through tau A, and gamma. So we're assuming the same slope parameter for each treatment arm. Error terms are epsilon 1,1, epsilon 1,2, all the way down to epsilon AN. Now this is the ANOVA setting, and this is the regression setting. And generically, it's represented like this. X deals with the ANOVA design, and Z deals with the regression setting. Now, that is all we have for this video. So stay tuned. The next video, we start talking about the different column spaces within the design matrix, and that's part 2 of this mini-series. So I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.